Good morning. My name is Savima Paranchal, and I'm excited to present our session paper, Collaboration is All You Need, LLM Assisted Safe Code Translation, a collaborative effort with my colleagues from Western Labs, Kent State University, and the University of Houston. Today, I want to talk about a new paradigm for translating code that challenges the bigger is better approach to language models. Code translation is a fundamental challenge in modern software engineering. It is the backbone of modernizing legacy systems and enabling a multi-language ecosystem. While large language models have shown incredible promise, they aren't a silver bullet. They're costly, can introduce difficult to detect bugs or hallucinations, and their performance often drops off with less common programming languages. This is the problem we set out to address. So, how do we solve this? Our vision is a framework we call UniTranslator. The core idea is simple. Instead of relying on one giant model, we orchestrate a collaboration between multiple compact and specialized LLMs. You would think of it like an expert committee of programmers, which master of a specific language, working together on a problem, rather than relying on a single generalist genius. Our goal here is threefold. First, to achieve high accuracy translation that are functionally safe and semantically sound. Second, to make this advanced technology accessible and efficient enough to run on common hardware. And finally, to effectively translate into low resource and less common languages. So here is a high level look at the unit translator architecture. It all starts with the director element, which acts as the orchestrator or project manager. The director doesn't just pick a tool, it dynamically assembles it based on the form's complexity and the specific languages involved, drawing from a database of benchmarked agent proficiencies. This team includes experts from our LLM forum, a collection of models which fine-tuned on a defined language. The initial translation then enters a decision loop. Here, our agent garden and the compiler garden scrutinize all the code that's getting generated. This generates a crucial feedback from compilation errors to logical inconsistencies found by the agents. This feedback is then looped back to the director, allowing the system to iteratively refine the translation until it converges on a correct and robust solution. So what makes UniTranslator different? Our first innovation is what we call concept-driven translation. The problem with many tools is that they perform a direct syntactic translation, which often misses the original intent of the code. To solve this, we introduce concept agent. It's a specialized LLM that we have trained on very specific documentation, code documentation, and fundamentals from textbook and documentation documents. Instead of just translating line by line, the concept agent first deconstructs the source code into a language-independent blueprint of its core logic. This blueprint then guides the specialist language models, ensuring that the final translation is not just syntactically correct, but that it preserves the true meaning and intent of the original code. This proves quite good for translating between languages with very different architecture. Our second innovation is how we ensure the code is correct. A major problem with LLMs is that they are prone to hallucinating. They might invent function names that sound right but doesn't exist, or get subtle detail wrong about how a language works. To combat this, we developed an NLI-based fact checker. We trained this NLI model on official programming language documentations, teaching it to distinguish between factual statement about the language and common misconception. For instance, a classical mistake is thinking that a Python's append method returns the list. Our fact checker knows this is a contradiction and can flag that incorrect code pattern. By catching these semantic errors before they even get to a compiler, we make the entire translation process much more reliable and efficient. So does a collaborative approach actually work? Our comprehensive results validate this. We used a team of compact, open source models like Gemma and Llama for our experiments. more specifically Gemini. First, we looked at highly specialized and challenging tasks, translating subjectively smart context to the moved language. As you can see, UniTranslator achieved absence success rate of nearly 62%, significantly outperforming Solmover, our previous work, a tool built specifically for this purpose. Yes, we evaluated our framework on the standard pixel cost benchmark. This chart shows what those scores where high is better. In several key translation tasks like C++ and JavaScript to Python, UniTranslator achieves most state-of-the-art results, demonstrating the broad power and effectiveness of our framework. But why does this collaborative approach work so well? To answer that, we ran an ablation study to measure the impact of each individual component on performance. As you can see from this chart, the full UniTranslator framework achieved the highest score, as expected. When we removed the NLM actuator, the score dropped significantly as more hallucination and semantic errors slipped through. When we removed the concept gauging, the performance degrades even further because the system struggles to bridge the gap between different programming languages. This clearly showcases that our hypothesis that every agent plays a critical role is that it's the synergy and collaboration between these components that builds or gives us this good result. This is better than achieving a result, and this result we get is far exceeds that of any single component or even a single standalone player. Looking ahead, we plan to expand our work to cover more languages, to include critical legacy languages like COBOL, and to train even more specialized agents for demanding domains like scientific computing and cybersecurity. One of the most exciting feature scripts is building a recipe recommender that can automatically suggest this team of agents for any translation job. Of course, we also recognize our current limitations. Highly domain specific code is still a challenge, and our knowledge bases will require continuous updates as programming languages evolve. These are key areas for our ongoing research. UniTranslator demonstrates that for safe and effective code translation, collaboration plays a key role in our framework. By orchestrating a team of specialized compact agents, we have created a powerful and accessible framework that is grounded in both conceptual and understanding and factual correctness. This multi-agent platform is a significant step forward for AI-assisted software engineering. Thank you. If you want to get in touch, that's my email and my QR code for LinkedIn. Also on the right, that QR code will lead you to our full paper if you want to read more. Thank you.